Hi, what we've got here is the Roland Juno-G, and I want to talk about fixing the Roland Juno-G disbalance of channels volumes, and I've got a solution for the problem of loudness and disbalance. I figured out that replacing the small SMD capacitors, 10 microfarads on 25 volts, will fix the problem of operational amplifiers balance on outputs and as well the loudness. I am right now working on the outboard, this one, and I will show you how to replace the SMD soldered capacitors, a small one, which will increase loudness of the operational amplifiers. As you can probably notice, the capacitors with the blue marks here, all of them were replaced by me, and I also decided to replace a few of them here. Totally I replaced 25 capacitors. It took me about like 1 day of very sharp work, and I will show you techniques on how to work with the bunch of small capacitors like this. They are all dead after replacing, because I believe they did not like the temperature which is used for desoldering process. The temperature is high because I don't want to pull the traces under the capacitor, and I will show you technique exactly how to desolder the capacitors without damaging board, and also technique on how to solder them with usual traditional iron solder instrument. And yeah, this unit sounds much balanced right now, and I will work on the output A, output B board. I mean the board with same capacitors like 10, 25, and also I will replace a few 100 on 16 volts here, this 2-1, and yeah, I will not replace the MIDI part because I believe this one working fine without problem, and I will replace one in the power supply chain as well. And this one is a mute chain which rules the moment when the output must be muted or not, just to prevent the loud click in a PA system. So as I told you previously, this board was removed, disconnected, and I work with the capacitors in a certain manner. I will tell you just now how to work on capacitors. There is the better sequence of replacing them from outside to inside, like this. I replaced them, I removed them in the order which allows me to move from less risk situations, like I removed peripheral capacitors and then move it to the center, and then in the process of soldering I place it first peripherals like these few, and then started to moving from peripheral and reachable one to center with less reachable, because if you solder one with less possibility to reach, then you will increase the reachability, I mean the comfort for working with the capacitor from like a tight space here. I'll show you which one. Let's say I soldered central one, and I will be left the 3 left and 3 right, and I started to work 1 left, 1 right, 1 left, 1 right, and then I saved my comfort possibilities with working with the capacitors, and it allows me to make a clean job without damaging the capacitors and so on. As well, here I remove it like 5, and then I worked with the worst capabilities to reach, like this board will not allow me to reach from that side, and yeah, it's kind of difficult. And then I added 1, and then I added 2 of those. So I usually work with 1. If it stacks or just like I don't like it, I to keep my mood nice and positive, I may switch to a different capacitor, boost my confidence with 1. I believe I can do a harder job, and then I get back to 1 with I have a kind of issue with soldering, and I will continue with my positive attitude on the other places. And now I will take it away, and I will focus clearly on this board, and yeah, I will explain how to make everything clear and 100% work. Yeah, let's get in a second part how to desolder the capacitors with 2 blade iron desoldering instrument. In this part I will show you how to exactly execute the replacement of capacitors on this board, as well as let you know a little about the process, how to overcome the limitations of some tools which will be used in that process. First, this instrument, because this dual blade desoldering iron is capable of catching the both sides of the capacitor like this, and then heating the bottom of the capacitor with contacts and letting it release, to solder and release. As you can see, that capacitor is quite small, like it is a 4 millimeters big, small, let's say, these two contacts. I'll show you by drawing my sketch here. You can see the capacitor is looking like that. This is the body, round body. This is the plastic canvas, and two contacts is going on one side and on the other side. And this is the board to which that capacitor is soldered. Yeah, a little more on that. This capacitor needs to be desoldered with the two blades. This is the blades of desoldering iron. The two heating blades are going to contact the board and hit these small parts of connectors. There are a few things that we need to avoid. We need to hit the body of the capacitor. I don't know how it will actually influence the performance, because let's say each of the desoldered capacitor which were removed from the previous main board were dead already on arrival. I don't know, because I already overheated it. But I tried to not hit it that much as I can, but my procedure does not allow this capacitor to survive. Let's say this instrument cannot desolder these small capacitors and leave it actually still working. And anyway, I tried and I created my procedure. And now I will explain how to prepare the capacitors and the board to let this kind of instrument works better. First of all, the preparation procedure consider we can have a top view on the capacitor. It consists the process of preparation. We have two contacts coming out of the capacitor. We are looking from the bottom, from top on the capacitor. These capacitors usually have contacts that comes out just like on 1 millimeter from one side and from the other, and the traces that allows us to solder them going on the bottom like this. We will have a few tries to desolder this capacitor, not to damage the traces of the board, and to prepare the quality attempts. We need to add a few drops of solder on one side and on the other. First, I will add a little flux on one side and on the other, and I will use traditional iron to drop a few small drops of the solder on one side and on the other. From this side of view, it will look like that. We have the body of capacitor. This is the plastic part, and a few drops of solder need to be added here and here. In this way, we will have a better contact of the blades of desoldering iron, which will come to hit the bottom part of the traces, and then allow us to remove this capacitor without tearing the layer of contacts, the supply signal chain, and leave the traces on the board intact for the further soldering process. One thing I have to add for desoldering process, that you, and this is the actually the main part of the desoldering process, while contacting the heat blades to the capacitor like this, you will need to regulate the tension of pressure on the board. You have to do it slightly, very slightly manner. After the contacting the left and right contacts, those small drops of the solder will transfer heat from the blades underneath of the capacitor, and you will able to slightly move the plastic part with this round, with this kind of motion. When you will find the body of capacitor moving as well with the plastic part of the capacitor, you need to think ahead of that process. You need to plan the trace of moving this capacitor away from the soldering pads. That movement cannot be upward. You cannot squeeze a capacitor and move it up, because you will tear the contacts. All you need is to add the heat to the drops of the, like that. All you need is to add the heat to the drops of the capacitor, move it like that, move it like that. And when you notice the body of capacitor is moving with your moving hand, like rotation movement, you need to move capacitor in the surface of the board. I mean, the axis of left, right, towards, or from towards your chest, or in different direction, but not upward movement. You need to propagate the movement from center to peripheral, like that. And in this case, in case of the board, I can show you, for example, this capacitor has no additional elements on the board, and I need just to add a little heat on to the left and to the right, and after it starts moving with my hand, I need just to shift it to move it in this free space, like that. I'm hitting and then moving here. In tight spaces like this, I can see the small SMD resistor here. You can see a lot of shadows, but here is the resistor, and by applying heat in this manner, I need to move that capacitor left or right, not upward. In that manner, I will leave the contacts under the capacitor in the same conditions of operational conditions to be able to solder another capacitor back. And in different locations, like here, I can move the capacitor up, like in upper direction movement, not in out of the board, but I mean up in this direction. This is the main tip to leave the board in initially working condition, and then to be able to solder the capacitor back to where it must belong. This is the theoretical part, and in the next part I will show you how to exactly execute it on many capacitors. I will just move from one to another, preparing it, just like adding a little a drop of a solder on left and right contacts. Then I will prepare a lot of them. Then I will actually heat the bottom board and contacts and remove them, all which is planned to replace. And then I will show you how to clean the pads and prepare for soldering. And I will show you how actually execute the soldering, and yeah, we will test the working unit with replaced capacitors on the board, and I will show you how to execute the test mode, which is an integral part of testing the Roland Juno-G. Thank you for your attention. See you in the execution part of the desoldering procedure.